Hello, welcome to the Dev Method. My name is Ricky, and we are doing some Rust programming yet again today on a live stream. And today's topic, very similar to all the other topics that we've talked about so far, which is 100 exercises to learn Rust. The link is in the description if you want to see. I'll go over how this project is structured, and then we'll jump in. We're actually close to the end. So if you want to see some of the beginning parts of me walking through this, that's in the previous streams. So I'm doing it off the cuff. I haven't prepared at all and looked ahead at any of the exercises. So you get to see in real time me stumble and fumble and get confused and try and figure out what it is we need to implement in order to complete the exercises. So yeah, that's what we're going to do today. Let me switch over here and we'll take a look together. So here we go. Okay, so here's the repo. Just wanted to show you this here. 100 exercises to learn Rust. I didn't make the repo, but you can see here that there are 100 exercises. There's a website that goes involved with this too. So there's rust-exercises.com/100 exercises. And it's like this little book here that you can walk through all the chapters. So there's calculator, tickets v1, traits, tickets v2, ticket management, and then you get to threads. And what we're on currently is futures. So we're talking about asynchronous programming in Rust here. So that's what we're doing. So yeah, the way this works is you go into the exercises, and each one of the chapters are a different section. So in this case, let's say it was the threads. We could open up each individual section within the chapter, and they're their own Rust crate. So you're able to build and run and test. But how do you know what it is you're working on? Well, if you go back to the website, which we have here, you will get to read something or other about the topic that you're trying to learn. Sometimes it's a little bit longer, sometimes it's a little bit shorter, but yeah, I would also recommend, since I've been through most of it now too, take some time to really read the code that they have there, so that you can maybe reverse engineer and see how you're supposed to fill it in. Yeah, so let's take a look at it together today. We'll look at the exercises. We're on futures. And I think we're at runtime or future. Maybe we're at future. And we're going to try and get to the end today. That's our goal. And we'll see how far we can get. Now, at any time, if we're unsure of what the solution should be, we could go to a solutions branch. So there they have all the solutions for us, which is something that we do from time to time. I wouldn't, don't treat this as like a test that you're doing in school and you got to try and figure it out and turn it in. I would say if you're learning, that's the goal. So that's what you want to be doing. And then take breaks if you need a break. Because when you're learning something, sometimes your head starts hurting because you're learning something new. So that's a good sign. Anyways, why don't we take a look at what we're doing today. And let's see here. So here I got the repo cloned on my computer. All right. Let's go to futures. Okay. Hopefully you guys can see this. And let's see, we have, let me double check runtime. I'm not sure if that's where we left off. Let's see. Okay, yeah. So when you open up these different files, it's typically a lib.rs that you're going into because there'll be tests that need to be run in order to pass the exercise. But another thing that you'll see is that there's to-do comments, and then sometimes there's the to-do macro, which is where you're supposed to fill in the implementation. So not only making it build and run, but then also passing the test. That's kind of the idea. So yeah, that's what we've been doing. So we've done this one. And let's see. So if we did runtime, let's see if we've done future. Let's see. We did do future. Okay, cool. So I think this is probably where we left off. Just a quick review. Basically what it's saying is that when we're spawning a thread, or not when we're spawning a thread, when we have an asynchronous function, what we're doing essentially is making a state machine out of this function. And there's like the initial state, and then there's like the completed final state, and then there's one to many states in between. So this one here, if we were to look at the diff, so I have what I have written on the right-hand side, and then what was written before on the left-hand side. You notice I'm not wrapping it in the winged braces or the block here. So yeah, so the idea here was that RC wasn't able to continue after we yielded. So the print line wasn't working. So yeah, that's because RC is not send, is that right? Or it's not sync? It's not send. So RC is not send. So that's the idea. So therefore, can't be suspended in this particular task because we have yield now. So we have to make sure that the value is dropped here so that the value doesn't extend past the suspension. So that's the idea. So that was that one. Let's see. So I believe now we are on blocking. Let's go into it here. Okay. All right. So we have the test below, and this is the only file. Sometimes there is a test directory as a sibling to source, and those are integration tests, so those need to be run, but I don't see that here. Let's see what we have to do here. I think this is where we probably left off because I don't see any changes in the file. So yeah, that's the only to do. All right. So the Echo server uses async primitives. When running the test, you should observe that it hangs. Okay. Due to a deadlock between the caller and the server. So using spawn blocking inside Echo to resolve the issue. Use spawn blocking inside of Echo to return the issue. So it's talking about here. So spawn blocking. All right, let's probably read the exercise material. But yeah, they're saying that this hangs. So we have a spawn, we're using Echo. And Echo returns, okay, so Echo is a future, so it's returning an async function because we're not awaiting it here. We have some requests. This is very similar to the past test here too, so it's just some text. And let me put it up closer to the top now. So with each bit of text here, we're sending it and then expecting to receive it back through a TCP stream or socket. Okay, so let's see. Yeah, they always call this a socket in these exercises, but I think stream's a better name for it because then it says socket split reader and writer. I don't know. Personal taste, maybe. Either way, let's see. Shutdown, buff, read. All right, and then it waits for something to join. And if there's an error, it's just ignored. But if there is an outcome that is favorable, we're good. And if not, if we have an error from that outcome, Then looks like we have something to do, some sort of code here to unwind or resume the unwinding so that we can propagate the error. Okay, so in this case, let's run the test and watch the hang. I think that's a good first step to do. Oh, it did not hang. Interesting. It says the Echo server uses non-async primitives. When running the test, you should observe that it hangs due to a deadlock. All right, maybe something has changed with either Tokyo or something or other, but I don't see a hang. But it wants us to use spawn blocking inside of Echo to resolve the issue. Okay. Let us look at the material for the exercise. All right, we are at blocking the runtime. Okay, so let's circle back to yield points. Wait, we're at the blocking one, right? Yeah, okay. Okay, so let's go back. Tokyo cannot on its own decide to pause a task and run another one in its place. The control goes back to the executor exclusively when the task yields. And so basically it's saying the future polls, which we talked about that in the last exercise, it returns pending until it's ready with a final result of some kind. Or in the case of an async function, when you await a future. This exposes the runtime to a risk. If a task never yields, the runtime will never be able to run another task. This is called blocking the runtime. Okay, what is blocking? How long is too long? How much time can the task spend without yielding before it becomes a problem? It depends on the runtime, the application, and the number of in-flight tasks, and many other factors. But as a general rule of thumb, try to spend less than 100 microseconds between yield points. Okay. Consequences. Blocking the runtime can lead to deadlocks. If the task is not yielding, if the task that's not yielding is waiting for another task to complete, and that task is waiting for the first one to yield, you have a deadlock. No progress can be made unless the runtime is able to schedule the other task on a different thread. Starvation. Other tasks might not be able to run or might not run after a long delay, which can lead to poor performance. Okay. Blocking is not always obvious. Correct. Some types of operations should generally be avoided in your async code, like synchronous I/O. You can't predict how long it'll take, and it's likely to be longer than 100 microseconds. Okay. Expensive CPU-bound computations. The latter category is not always obvious. So this one here. For example, sorting a vector with a few elements is not a problem. The evaluation changes if the vector has a billion entries. Yeah. Okay. How to avoid blocking. Okay, so you have to avoid blocking the runtime, assuming you must perform an operation that qualifies or risks qualifying blocking. You need to move the work to a different thread. You don't want to use the so-called runtime threads, the ones used by Tokyo to run the task. Okay, so Tokyo provides a dedicated thread pool for this purpose called the blocking pool. You can spawn a synchronous operation on a blocking pool using Tokyo's spawn blocking function. So spawn blocking returns a future that resolves to the result of the operation when it completes. So here, do other stuff in the meantime, and then await this work. That's what that's saying there. So you're awaiting. Similar to threads, but here we're using await because it's async. All right, so the blocking pool is long-lived. Be faster. Okay. Further reading. Check out this person's blog post. All right, let's just take a quick look. Whoa, that's very bright. Blocking versus non-blocking code. Yes, blocking. Okay, now it's an async function though. Well, this was async main. Here's an async function. Join all of these. Okay. Well, I didn't see really, I'm gonna skip that part there. I didn't see where, first of all, we didn't hang. But then use spawn blocking inside echo. So spawn blocking. So they saying Tokyo spawn blocking? Where is spawn blocking? Oh man, maybe we gotta go look for it. We had Tokyo spawn. Yep, we have spawn. Where's spawn blocking? Tokyo net. Maybe sync? Not really sure. We might have to Google search it. What if I typed in, here we go, spawn blocking. Aha, task, spawn blocking, okay. And then what is this here? So it also returns a result. Okay, or a join handle. So handle, async move. And then put this in there. Oops. Okay. It doesn't like this because of the function signature. So handle await unwrap. Usually how we've done it. Okay. So I think I solved that part. But what is going on here? Okay, expected a function once closure. Okay. Is there anything else? But it found an async closure. Okay. Interesting. So spawn blocking takes a function once. Okay. It's interesting. So I'm not sure that this exercise works as it is intended right now, just because run the test, we're supposed to observe the hang. But I don't see the hang. So maybe we just look up the solution, because maybe this exercise doesn't work. I did notice there's maybe just a couple of differences in syntax with their solution versus the Rust version I currently am working on, which is the latest. Okay, their solution. Okay, I don't see it here. Use spawn blocking. Spawn blocking. See, it's only mentioned once here. So I'm a little confused on this. Not sure what we're supposed to learn here. But I did find spawn blocking. But it takes a function once, and therefore it's not an async function, right? So what would be this issue? loops. Yeah, but then these are awaits. Oh, I don't know why loop is there. Here, let's do this. Interesting. So it's putting loop in front of this. Yeah, I don't know. I can't really tell you what's going on there. Let me undo that all. I don't know, guys. Maybe it's just worth skipping this one. So I don't really quite understand it. Here, maybe let's do spawn blocking example in Rust. Sorry for the very bright screen here. All right. There we go. That's a little bit better. All right, so spawn blocking. Do we have like a code example? Okay. Oh, and you await the spawn blocking? Okay. So maybe what we're saying here is see, spawn blocking. Whoop, did that wrong. There we go. Do all this in there. All right, but we have all these errors. Yeah, so maybe spawn blocking goes. Yeah, each one of these can throw an error. So that it just doesn't make any sense to me. Okay. All right. I think that'll be the first exercise I'm just not really sure about. Maybe instead of propagating the error, I'm supposed to unwrap instead, and that's how they want me to do the exercise. So I don't totally get it. And their solution, oh no, that's the main branch. Okay. All right, so let's go to the solution. There we go, okay. Okay, so their solution, oh, I see. You have to say what the result is, which is the same as the signature for here, but they don't await the spawn blocking. Okay. All right, that I feel is a little tricky. So here they did this. They, after getting the, let's see, socket, after getting an TCP socket, that's where they did the spawn thread, or spawn blocking, sorry, move, but they have to say what the return type is, and it is the same as the function signature. Okay, and then we need to do this, right? Or are we returning it? Yeah, that's all it is. Take this, put it in here. That doesn't work. Yeah, spawn blocking. Move. Oh, I have the wrong syntax. All right, it is a function with no parameters, but returns a result. So that's that there. So now what is going on here? Oh, and then, okay. Right, so eventually we need to return okay. All right, so if we run the test, it should also still pass, which is good. Okay, so that means it's still writing the contents from the reader into the buffer. We're using this buffer. Okay, so all right, well, I guess that works. I don't know, this is definitely a weird one for me. Anyways, I think we just move on. I don't know how common that is. So that was blocking. Let's go to async aware primitives. All right. All right, to do, the code below will deadlock because it's using the standard libraries channels, which are not async aware. Rewrite it to use Tokyo's channels primitives. You'll have to touch the testing code too. Okay, so we'll have to touch the testing code because we're converting from channels to Tokyo. All right, let's see. So we got this thing called Pong. We got this thing called message. And there's our channels module. Multiple producers, single consumer. Okay, let's look at the tests. Okay, so the test is called ping and we're calling Pong as in the test. That's the idea. And we're gonna send it a message. So there's our channels. All right, cool. Okay, we have two channels we're setting up. All right, so the sender from the first channel sends this message, which is just the word Pong, which ends up being a string. And it's going to send back a message on this channel, on this other channel here. That's the idea, at least that's what it seems like it's supposed to be. But then, okay, so then we're doing a Tokyo spawn on this async function, okay. And we're passing in the receiver. So then in Pong, we receive this message. Looks like we're gonna print to the console or standard output. Create another channel and respond back. Interesting, the new receiver. The past in, oh, because this is mutable. Interesting. Okay. Okay, so we're supposed to use Tokyo spawn here instead of channels. And we'll have to touch the test to do that too. But channels is for sending messages back and forth. Does Tokyo send messages back and forth like that? Okay, let's just run the tests. Let's see what happens here. All right, so it says it's a deadlock. Yeah, because I don't quite get why we're resetting what we're passing in. Because then this receiver never gets called, right? So the sender is sent to Pong. So does Pong ever send? It does. Send this message. But this is where I think it's a little weird. I don't know why we're doing this. Oh, because you can send it back and forth. Okay, it's a little weird. All right, so we're supposed to use Tokyo for this. So yeah, it's definitely clearly a deadlock here. All right, so we got to fix this. This is the part where I'm not really sure about though. Like, am I sending asynchronous functions back and forth instead of these channels? I think that's what that means. So let's read the instructions again. The code below will deadlock because it's using channels, which are not async aware. Okay, yeah. So rewrite it to use Tokyo's channels primitives. Okay, so Tokyo channels. Let's read the content. We'll leave that there. So Tokio has channels. So if you browse Tokio's documentation, you'll notice that it provides a lot of types that mirror the ones in the standard library, but with an asynchronous twist. So locks, channels, timers, and more. When working in asynchronous context, you should prefer these asynchronous alternatives to their synchronous counterparts. To understand why, let's take a look at mutex, the mutually exclusive lock we explored in the previous chapter. Okay. So going back to mutex, atomically reference counts a mutex storing a vector of U64. We get a guard or a lock to it. We call something and we await with that lock. Guard is dropped here. Okay. V as the body of HTTP call. Okay. So mutex guard and yield points. This code will compile, but it's dangerous. We will try to acquire a lock over a mutex from the standard library in an asynchronous context. Yeah, I see, because it's async function here for this run. And then we're awaiting. Okay, so then we hold on to the resulting mutex guard across a yield point. Yeah, that's what this is here, across the yield point. This is the yield point. All right, let's imagine that there's no task executing run concurrently on a single thread at a time. We observe the following sequence of scheduled events. So we have task A, which acquires the lock. And then task B tries to acquire a lock. So we have a deadlock because task B will never manage to acquire the lock because the lock is currently held by task A. Yeah, okay. So like in the HTTP call, we try to get another lock, I guess is what it's saying. Or something else after here. You can try and get the lock. Okay. So won't be scheduled again until the runtime cannot preempt task B. All right, so there's a Tokio sync mutex. So we still use the arc from the standard library, but now we use Tokio sync's mutex to get this lock. The guard is dropped here. So acquiring the lock is now a asynchronous operation which yields back to the runtime if it can't make progress. All right, so going back to the previous scenario, so you go here, but now since we're using the mutex from Tokio, so if it cannot acquire the lock, it yields to the runtime. So it goes back to task A. Then it waits for a ready or complete of this or another yield. Releases the lock. So at some point this has to release the lock and then we can acquire the lock. Task B is suspended in the same time. Okay, so all good. Multi-threaded won't save you. We've seen a single-threaded runtime as the execution context in our previous example, but the same risks persist even when using a multi-threaded runtime. The only difference is in the number of concurrent tasks required to create the deadlock. In a single-threaded runtime, 2 are enough. In a multi-threaded runtime, we need like n+1 tasks, where n is the number of runtime threads. Okay, so downsides. Having a async-aware mutex comes with a performance penalty. Okay, so if you've considered that the lock isn't under significant contention and you're careful to never hold it across a yield point, you can still use the standard library's mutex in an asynchronous context. Okay, so if you can ensure that the deadlock won't occur, this will be better for performance, is what it's saying. But weigh the performance benefit against the liveliness risk you will incur. All right, so we use mutex in the example, but the same applies for a read-write. Okay, so for that lock as well, semaphores, etc. Prefer async-aware versions when working in asynchronous context to minimize the risk of the issue. Okay, so it's just saying if we're going to do some async functions here, and we're using Tokio, might as well stay with Tokyo's mutex rather than the standard library's mutex. So let's look back at the exercise because it's using standard channels, but now we want to use Tokyo channels. So let's see, we have Tokyo channels here. Can we search? All right, Tokyo channels. Oh, the documentation. Oh, lots of good stuff here. Let's see. Here we go. So let's see. It said it mirrored the same structure as some of the modules in standard library. So Tokyo sync. Let's do that. Tokyo. All right, we're gonna get some errors, I'm sure. All right, we got a couple. Oh, and then here, we're going to use Tokyo as well. So I think that that's where I'm going to start the first updates. And then basically every time we do channel, that's where we're getting the issue. So what does it say? Takes one argument, but 0 were applied. So what is the argument? Buffer size. Okay. What should the buffer size be? Yeah? So we need some sort of buffer size. I'm going to give it all the same size. Let's go up here. Okay. Maybe that's enough. We will see. Okay, we got the sender here. What else is broken now that we've done that? The unwrap. Oh, because it's probably, we want await. Yep. And we want wait here before we unwrap. Yeah. Actually, let's undo that. So let's see. So if we have a response receiver dot receive, that is an async function. So we await that. Okay. And then we have an option. So what can we do with the option? We can unwrap it and we get the message. The message has a payload. And that payload is a string. All right, so we needed to .await .unwrap like so, and that should work. But what is this saying? Cannot borrow response receiver as mutable and is not declared as mutable. Okay, so it's saying this needs to be mutable. All right. So the tests look like they are good to go, but what about up here? So maybe the message has to be mutable? Is that what this is going to say? Mismatch types. Okay, found a result. All right, so we have a receiver from Tokyo this time, and we call receive on it, and we get an option. Okay, the option is a future. So we need to await that here. Yeah, so if we await that, then we have an option of a message. And then therefore it's not a result type, so we just do this. Oh, yeah, we do this. Not instead of okay, it's sum. So let me take that out there. All right, and then the unwrap, it needs to await again before we unwrap. Okay, I think that is what we needed to do. So that's pretty cool. I like that structure where we had to change, instead of using the standard library, here I'll show the diff. So once we changed our use from use standard library to use Tokyo, then same thing in the tests. So we're here on the tests as well. Yeah. Then we had to go back and make sure that we're awaiting, because we're now in the asynchronous context with Tokyo, and we are using Tokyo test. So we have the Tokyo runtime. So then basically everything that had an error after that just needed to be awaited. And then I'm leaving in the code there that they are force unwrapping everything, but that was the difference there. The other difference was the channels needed to have some sort of buffer size to them. So yeah, sure, give it a buffer size. Let's see if this works. Cargo test. Whoops, spelled that wrong. Cargo test. All right, it passes. Nice. Okay. All right. I like that. I like learning that. So basically, if I'm going to use async functions, and we're already using Tokyo, because we need some sort of runtime. Tokyo itself, you want to use its channels or its spawn instead of thread spawn to avoid deadlocks on asynchronous functions. Okay. Sounds good. Let's move on. All right, so that was async aware primitives. Let's do cancellation. This is exciting. Okay, so fix the assert equals at the end of the test. Do you understand why that's the resulting output? All right, we have some Tokyo stuff here again. Running something here, accepting, doing some sort of timeout, awaiting that, returning the buffer. So I guess whatever we read into the buffer, we're going to return in the run. So let's see. Let's get to the point of the run. So we have a listener, get the address, got our messages we're going to send, and here's our spawn with the async function of run. Okay, so timeout. Okay, so we have a duration timeout. So it needs to do it in so many seconds. And where's our timeout? I guess, let's see. Requires a feature to complete before specified duration has elapsed. Okay, so it needs to run, but if the time runs out, an error is returned and the feature is canceled. Okay, so do this now. But 20 milliseconds is maybe pretty short. Not really sure. Probably depends on your system. Let's see. We get a socket and we're writing to it. Message. We split the message in half. Is that what we're doing? So we get the beginning and the end of that message. Is that what that's saying? Okay. Write all the bytes. Oh, and then we sleep. I see. And then the rest of the bytes. That is what we're doing. And then we shut down. Okay. And because of this sleep, it is longer than what we're timing out in the run function, giving the run function enough time to actually hit the timeout. Okay. And so now it's saying that the buffer equaled So this is our handle. Because that's the return type, we get the buffer, the vector of U8s. Then we're going to transform it from U8s to UTF string, UTF-8 string. And it's saying buffered equals nothing, but the instructions said fix the assert at the end of the test. Do you understand why that's the resulting output? So I'm guessing we're reading till the end of the buffer, and what we're doing is we're sending each one of these hello from this some task. I don't see any new lines, so I think what it's saying, hello from this task. I don't see anything about spaces either. Okay, so before I do that, let's run the test. So cargo test, right? And hello from this task. And I think I know that this is also wrong because I just glanced at the test results. And if I look at this closely, because I'm looking here at the left and the right, maybe let's zoom in. Yeah, okay. So this is what we got back, but this is what I guessed it was going to be. So it looks like we're getting the first 2 bytes of each one. And if that's correct, first 2 bytes, why is that? Read to the end of the buffer. Maybe because of the timeout. It's only reading to the end, and it's timing out. So it is done reading to the end prematurely. Oh, I see, message size. Okay, so we're reading from 0 to the message size. And what are we passing in as the message size? All the messages, so 4. I see, so 4. And so then that means 0 through 4 times. So we're only reading this 4 times, and then the timeout happens. Accept and listen for the next one. Okay. Yeah, I think it's because of this timeout, is what I'm guessing. I suppose. All right, let's read the contents of the exercise. And let's see if there's anything else we can understand. All right, so cancellation. So yeah, it's being canceled because of the timeout. So what happens when a pending future is dropped? Yeah, so it wasn't done. So the runtime will no longer poll it, and therefore it won't make any further progress. In other words, its execution has been canceled. So in the wild, this most happens when working with timeouts. Yeah, so that's what we had here. All right, so here's their example of a timeout from Tokyo. We have the duration, and then we have the future. So let's see what ours look like. Let's go up a little bit. Okay. So here's our timeout, and that is a duration. And then we have the async function, an anonymous async function. All right. And let's see, when the timeout expires, the future returned by HTTP call will be canceled. So let's imagine that this is the body. So in ours, it's just reading a buffer. Okay, so at some point this could be canceled. So maybe in the middle of this, awaiting for this to write all. Each yield point becomes a cancellation point. Oh, okay. Yeah, so this could be canceled here. So in this case, it would be this part. This part is a cancellation point. So can't be preempted at runtime, so it can only be discarded after it has yielded control back to the executor. All right, this applies recursively. So the write is likely to have multiple yield points in its implementation. Ah, I see, yeah. So reading to the end has multiple yield points in its implementation because the stream came from this listener, and this listener came from, where did it come from? Tokyo, okay. So in Tokyo, there is other awaits inside this read to end function. That's what that's saying. Let's see. So reads all the bytes to the end of the file, placing them into the buffer. Okay, all bytes read, source will append to the specified buffer. This function will continuously call read to append more data to the buffer until read returns okay with 0 left. All right, there are errors. Any bytes that have already been read will be appended to the buffer. All right, doesn't talk about its implementation. But yeah, so that's what I'm guessing is happening. Okay, so if that's the case, it's perfectly possible to see HTTP call pushing a partial request before being canceled, thus dropping the connection and never finishing transmitting the body. So we've never finished reading the buffer, is what I was saying. So cleanup. Rust cancellation mechanism is quite powerful. Okay. And it allows the caller to cancel an ongoing task without needing any form of cooperation from the task itself. At the same time, this can be quite dangerous. It may be desirable to perform a graceful cancellation to ensure that some cleanup tasks are performed during aborting the operation. So for example, a transaction in SQL. Yeah, okay, this seems good. All right, so you begin your transaction. Update the balance, decrease the balance, do multiple operations here, but if and then you commit. But if one of these fails, you want this transaction to roll back. So on cancellation, is ideal to explicitly abort the pending transaction rather than leaving it hanging. Yeah, so Rust unfortunately doesn't provide a bulletproof mechanism for this kind of asynchronous cleanup for operations. All right, most common strategy is to rely on the drop trait to schedule the required cleanup work. This can be by spawning a new task in the runtime and queuing messages on a channel, spawning a background thread. The optimal choice is contextual. So depending on what you're doing. Interesting. Okay. So canceling spawn task. So when you spawn a task, Tokyo, you can no longer drop it. It belongs to the runtime. So nonetheless, you use a join handle to cancel if needed. All right, so you get your handle. I see you. So you call abort. Should be cancel, but okay, abort. All right, read further. Be extremely careful when using Tokyo's select macro to race two different futures. All right, retrying the same task in a loop is dangerous unless you can ensure cancellation safety. All right. So if you need to interleave two asynchronous streams of data, prefer using, okay, merge instead. All right. The cancellation token may be preferable to the abort in some cases. Okay. So fix the assert at the end of the test. You understand why that's the resulting output. I wish someone, I think I understand why, but I don't quite understand why it's always the first two letters. I guess that's just from our system. Maybe someone in the comments would know why. Can help me explain. All right, so let's run this. Cargo test. All right, we are good to go. And we're moving on. All right, so that's cancellation. And now we have the outro. All right, the outro is probably really simple. All right, this is our last exercise. Oh, it's probably not simple, actually. So let's go down a more unstructured path. Try writing an asynchronous REST API to expose the functionality of a ticket management system we built throughout the course. It should expose endpoints, create ticket, retrieve ticket details, patch a ticket. Use Rust's package registry create.io to find the dependencies you need, if any, to build the system. Oh, wow. So we do already have Tokyo, but I guess anyhow we would want. All right. Well, I feel like this is going to be a long time to think about this. So, but I want to start with some of the stuff I had from the previous chapters. So, what if I went to my threads, and then here's the patch code, and I think I could take the stuff from data here. So let's see. Whoops. All right, so data. Go here and put in the data. Whoop. Is that not data? Huh. Okay. I want to get out of here. Data. Yeah, that's, why did I copy and paste that? All right, so back to threads. I think it was under patch here, source, data. All right, let's just get this, just copy here. All right, and back here to our outro. Okay, paste this in. But they don't even have any tests for us to run. They really kind of left this completely open. All right. And then we need a client. So that would be the store, store.rs. So if I go back, I go to the threads, go back to that patch here. Store. Here we go. I think this is what we would want. Okay. Outro. Store. Put that in there. I think that's what we want. But then we need to start up the server. So let's see, if we went back to threads, and again, patch. I don't even know if this is the right way to do it, but all right, so we have a client. Where was the server part? All right, so then we did this like launching of the server. So what if we did just copy it all and went to futures, outro, lib. All right, put it all here. But here we'll use Tokyo. We don't have sync channel, we just have channel, I believe, right? Sender, I think it's just it. All right. Instead of sync sender, we'll just do sender. Instead of sync channel, it will be channel. And then we'll do, I don't know. Sure, that's the buffer there. All right. This will be wait there, because this is now an async function. Okay. And then we need another channel again here too, channel. Okay. And we're gonna get to the async function here, and we await here. Okay. And this is an async function. And we have channel here. Whoop. Whoa, channel. Okay. And we have dot await here. We'll probably have to go back, but I'm just trying to clear up at least a couple of things. And we're not going to use this overload error. Yeah, we'll just do anyhow error. So let's see. Yeah, so then anyhow error. Just do that. That's what I was missing. Okay. Yeah, and then get rid of that. Okay. And then anyhow error. Okay. Okay. That means to get rid of this. Okay. Okay, channel capacity. Look at that. Passed it in. Okay. Oh, and this is sender. Whoop. Sender. Good to go there. Server needs to be async as well, because we're going to have to await. Don't know about the rest of this stuff though. Seems a little weird. Maybe we gotta get some spawns in there. Because it's no longer a result type, I think, right? So X receiver. Yeah, it's an option. So instead of okay, it'll be some. Yeah, let's take this out. And this will be some. I hope this is a good way to do this. And then this is, instead of an error, it's none. Okay. We have some other errors though. So we keep saying it's a result. So the receiver, it's because it needs to be mutable. Is that why? Yeah. Okay, so mute and mute. All right, so I may have fixed most of the issues. Okay. Mute. But now I need a test to test this out. So, do I write it in here? They had it as integration test in the patch. So what if I did that? Oh, but the tests are going to be a little weird, right? let's see what they did in the patch tests. So we do threads, and we do patch tests. Okay. Yeah, they didn't open up any addresses or listeners or whatever. So in this case, maybe what we do is we take a look at what we just did with futures. No, not that one. Maybe the runtime one? Oh, but this is 2. So let's go back to async function. Okay. Yeah, maybe we take this one, this test here, and we'll kind of modify it for our own purposes. So we go to outro lib. Okay. So what does that mean? It's going to get errors, TCP. Let's get one in there. Okay. And it's not echo. It is spawn the server. Maybe we launch it. Oh, yeah. And then here, this needs to be Tokyo too. All right, so we didn't quite do everything. D Tokyo. Because server is async, yeah? Yeah, so server is async. So we do this. Tokyo, I think it's just Tokyo spawn. Yep. Okay, so there we go. But we do have another error somewhere. Okay, so this is we're going to pass in a listener. So instead of echo, we have a server, I believe, or launch. Yeah, okay, so this is client server stuff. So we're getting close, I think, to a solution. Not sure what they had in mind. So before I go further down this path, because I'm basically returning a client that would then communicate, because it spawned the server here. So I would say launch instead of this part. So I'd say launch with the size that I give it. So that spawns, that does the Tokyo spawn there. But this is sending messages to and from that, and we're not listening for messages, are we? I am curious. I know it says it compiles, but yeah, okay. Ticket fields. Oh, ticket fields. I need some ticket fields. Okay, so that is in here. I need ticket fields. All right, where is that in the patch? That was in here, and we did this. Ticket fields. Oh, this is in the helpers. Okay, so let's maybe go back. And we go here, and we get our helpers. Okay, so if we went here, futures, outro. Okay, back in the outro. I put this in the cargo toml file. So I want to go to ticket helpers. I just want to check out the code that's there, if that will help us. Tickets fields. It does use this error. Okay, maybe that's fine though. Okay, we're mixing this error and anyhow, maybe that's okay. Okay, so I'm back into the outro. Cargo check. Yes, okay, so now we have some other errors that come up. So let us take a look. Okay, receiver await. Oh, because it needs to be mutable. Okay. And then therefore, okay. Does there need to be like a Tokyo main somewhere? No, we don't need that. Okay. Let's go down. All right, I don't know what's gonna happen if we run these tests, so let's try that. Go test. Yeah, I figured something would block here. All right. Because it's waiting for a particular message that is not coming through. So that is because the launch returns a client. Okay, so client dot get. Now we need to insert a ticket. So let's do a draft. Ticket draft, which is got a title, my title, okay, and description, got two string, right, these are strings. What's going on here? Oh, it needs a ticket title. Yeah, okay. Ticket title. Ticket title. Okay, just a string. My title. Okay, now what? Contains private fields. Well, how do we create a draft? Interesting. All right, so maybe we didn't get that far of creating a draft. The ticket fields. Ticket title. Yeah, how do I create you? Ticket title. Constructor is not visible due to private fields. Pub? We pub it? All right, let's go back to this. Let's take out these fields here. Let's just do regular strings just to get us moving along. So that would be string. Oh, we need to take out the cargo toml file. Okay. Here, let's close this down here. Let's go here. All right, yeah, so it's just a string. String, and this will be a toString as well. As soon as we get rid of string here and going. Boom, boom. All right. Yeah, goodbye. Don't need that. All right, we are still building, still fixing our errors. Okay. All right, so we got a client. I don't know that we're sending, I don't know if we need this TCP stream. Although, is that what they wanted us to do? Asynchronous REST API, yeah, okay. So maybe the client will, on insert, instead of using these channels, yeah. All right, yeah, we have quite a bit of structuring here to do. I don't know. I think I get the concept. I'm gonna look at what they have for the solution. Are we on the solution branch? Yeah. Let's look at futures. In the outro, let's just look at one possible outro they have, because I feel like doing everything else might take a long time. Oh man, they don't even have a solution for us. Wow. So we're left up to our own to do it. Nice. All right. Well, I don't think I want to finish the rest. I don't have enough time to do that. But I don't know that it's worth it to refactor all this, because did we ever do a, just wondering if we ever did an HTTP call anywhere. Let's see. All right, here's the listener. Got the address, spawn the echo. Yeah, we never did HTTP, so it's a little strange for them to ask us here. So let's do, if I went to Safari, and then let's do like HTTP in Tokyo. Yeah, it doesn't do it. We would need another library, I think. I don't know. I'm not really sure. HTTP call to localhost Tokyo. Request. Yes, I remember this one. So you can make an HTTP call with request. I suppose it's open-ended because there's also like libraries you can use and such. Yeah. My internet's really slow. Okay. Yes. Okay. Well, it's thinking. Can I click it again? Nope. All right. Well, there we go. I think it is safe to stop there for now. So thanks for watching, guys. Yeah. All right. So I don't have a full HTTP server set up because they never showed us how to do HTTP calls here. And I'm guessing I'm just going to have to pull in a library to do it and not through Tokyo necessarily. So yeah, I think that's what we're looking at here. All right, kind of stinks that they leave you hanging. Yeah, it's saying, look, okay, so look at the dependencies you might need, if any, to build this system. All right, super advanced for threads, or for futures, rather, not just threads, futures. Cool. All right. Let's see. All right, guys, thanks for watching. Take a break because, yeah, I think that last part, it's good to leave open-ended, but it did feel kind of like falling flat at the end because I didn't have an example. And it really wants you to explore. So I think maybe that's what we do in a future video or something like that is since it's so open-ended, there could be so many right answers out there and there's so many different frameworks. Maybe that's what we do in the future is make some sort of HTTP endpoint. Maybe we'd use, well, there's a couple out there like Leptos. I don't know if it's gonna load because my internet has been not so great. Yeah, so there's like Leptos here, which is for full stack front end, back end. Let's see, basic component, testing, function, signals, routers. Yeah, a lot of front end. Okay. I see. So here's your form. I see. So server, API. So yeah, that's one way to do it. Query the server. Yeah, so I mean, for us, we would just be saving it in memory. So I don't know. Maybe adding a database might be good to do. That might be good for us to do. Follow. Okay, so let's see. That was one of them. Leptos. What's the other one? Yeah. All right. So Dioxys. Turi, we could do a front end, like Electron style application. That would be cool. But yeah. So Dioxys is another one. Just push this over to the side of my big head. You can see here you write some HTML, right? So you can have like an actual website to the ticket stuff. Creating UI, fetching data. Here they are using request again. And here I'll just zoom into example of what it would be like to write that code. So you got your GET request, yeah, or like your post, your patch, and you give it the address, you await, and you go from there. That's the idea. Yeah, and so what are they putting this in? They're putting this into the button for the on-click. So the framework kind of handles some of that for you. Yeah. All right, so maybe that'll be something we do in the future. But thanks for watching. If you guys have questions, you can leave them in the comments. You can look at all the other Rust videos that I've also posted for the channel too, and those are based on the Rust programming book. So if you need some sort of like auditory visual guide as you walk through that book, I would go there to take a look at it. If you want to see the past streams, we've done the past streams as well on this 100 exercises to learn Rust. And we've gotten to the end. We didn't do the last outro thing because there's a lot of different ways we could do this. And it also would require us to do some HTTP calls over a REST API. So I think that opens up a whole nother can of worms of something to learn. So maybe that's a future stream later. But other than that, you know, take care, have a good one. And I'll leave you with just looking at this code.